Right, today's video is going to be on correlation, and I may cover regression. Not sure yet. At least I'll explain to you what it is. Correlation is finding a relationship between two or more variables. Now we're going to talk about variables like independent, dependent variables, just like we did with hypothesis testing. Our independent variable is basically going to be some kind of treatment, and in this case it's going to be a predictor. So we're going to actually try to predict the future using a regression analysis, and we'll take you back to like 8th grade algebra, where we're going to find the slope and the intercept of a grid, and that will give us a good determination on how we can predict future events with correlation and regression. Now, back in the late 1800s, a mathematician by the name of Sir Francis Galton basically invented the correlation coefficient. And there were a lot of people out there who were looking for something like the correlation coefficient so they could find a relationship between variables. One professor in particular, his name was James Cattell, and he was a professor at the Pennsylvania University. And he was collecting data for 10 years on what he thought was variables that would relate to intelligence. So he was working with intelligence. So once Sir Francis Galton developed this correlation coefficient, James Cattell, basically started correlating all of his data, and he found in his results that none of the variables that he thought had something to do with intelligence did not have anything to do with intelligence, so he scrapped his work. He should have kept going because he was onto something. So other people like French psychologist Alfred Binet used correlation coefficients to actually develop a really, really good scale for intelligence, and we actually have that in use today, and it's called the Stanford-Binet. So without further ado, I'll get into what correlations are all about. So we're going to have a y variable, some kind of variable, and then we're going to have an x variable. And for this purpose, let's just say that I'm going to hypothesize that height and weight are positively correlated. And when I say positively correlated, I'm going to say as weight increases, height will increase, or when height increases, weight will increase in a positive direction. So I'm just going to take height, and I'll put that on, I'll put that on the x axis here. So height we'll just use in feet and inches. So we'll go with a 5-footer. So someone who's 5 feet tall, we find some people out there and we measure their height and we weigh them, and this person in particular here is 5 feet tall. They're going to weigh 110 pounds. So 110 pounds. Now we find someone that's 5 feet 5 inches and they weigh 125 pounds. Now I get someone who is, I'm going to change that to 5 feet 6 inches. Now I'm going to have a 6-foot person. And that person weighs 150 pounds. And then I'll find someone that's 6 feet 6 inches, which is very tall. And that person, let's say, weighs 175. This is just for an example. I know that these numbers are probably not accurate. But I get these people and I say, okay, this 5-footer is 110 pounds. So I'll plot that here. Now I've got a 125 pound person. That person's 5 feet 6 inches tall. The 150 pound person is 6 feet tall. The 175 pound person is 6'6". So if that is all the data I'm dealing with, I have a perfect positive correlation. and I can actually plot what's called a regression line right through the middle of that data, and it will all line up perfectly. So this should be here. So all these data points are going to line up perfectly on a perfect positive correlation. Now your correlations are going to range anywhere from a -1 all the way to a +1. Now the strength of the correlation is going to be dependent on the number. So if we have decimals, and how we're going to get a decimal, let's see if I have a person who weighs 110 pounds, but they're not 5 feet tall, they're 5 feet 3 inches tall. So that's going to pull this, so it's right here, so this lines up here. So this is going to deviate, and we already talked about deviation numbers, it's going to deviate from the regression line. And if I have a 5-foot person who weighs 115 pounds, that's going to push this number up here. So again, we're deviating from that regression line. So if I have another, these are called scatter plots, and I have data points, and I can see that the data points are moving in a positive direction. As this variable goes up, this one goes up. And my data looks like this. Now my regression line will go right through the center of that data. So think of the regression line as the average. And anything that deviates from the average is going to pull the regression below a perfect 1. So I'm going to draw my regression line through the center of the data, and any dot here that's off of that regression line is going to deviate from that average. I think that's a good way to actually talk about it. Another example would be, so I'm going to have an average, let's say that I'm trying to work on my long drive in golf. And so I go out and I hit 100 golf balls. Well, probably, if I'm lucky, maybe 2 or 3 may be exactly the same distance, but none of them may be exactly the same distance. They're probably all going to be, a certain distance, and they may vary in right or left. They're never going to be straight. So I hit 100 golf balls, and they're going to vary in distance, and they're going to vary from side to side, and we call that the standard error of measurement. When I look at the distance from side to side and the length, and I look at the variability of all that stuff, I can calculate that and find what's called a standard error of measurement. So nothing is going to be exactly the same all the time. So there's going to be error in those different measurements, and that's what I'm looking for here. And I can do what's called an R square. When I finally find R, and I can square that number, I'm going to account for all the variance. So it's called a variance accounted for when I square R. So you'll see that in your textbook. Now, when I have a relationship, and it can be a strong relationship, let's just go ahead and put some parameters on these relationships. So 0 here is basically no relationship. I have no relationship. So my scatter plot is going to look like a shotgun blast. So it's going to look like this. There's no way that I can draw a regression line through this or this. It doesn't have any shape to it. The data is just all over the place, and there's going to be no relationship whatsoever between variable X and variable Y, or variable Y and variable X. So I'm going to go ahead and erase this.